Hello everyone. Last class we already discussed about gears. Okay, so gear portion we already completed in module 4. Today's class will discuss about third topic. So total fourth module 4 topic is there. First one is materials. Second one is joining process. In that joining process, soldering, brazing and welding portion is there. In third topic, belt drives, and fourth topic is gear drives. So we already completed gear drives. Next we'll see the belt drives portion. Okay, so what is belt drive? So gear drive as well as belt drive is a device which is used to transfer of power from one shaft to another shaft. So belt or ropes are used to transmit power from one shaft to another shaft by means of pulleys. Okay, with the help of pulley, so power transmission take place. So belt drives, with the help of belt drive, power transmission take place from one pulley to another pulley or one shaft to another shaft with the help of pulley. Okay, so in gear drive that is also same thing. The power transmission take place from one shaft to another shaft with the engagement, but here there is no engagement between one shaft to another shaft. So large distance we can transfer power with the help of belt drives. Okay, so the pulley which is rotates at the same speed or at a different speed. So pulley having different diameters. Based on that we can increase or decrease the speed of the belt or shafts. Okay, we can increase or decrease decreasing the speed of the shaft with the help of these pulleys. Okay, so that is nothing but belt drives. So belt drive is a device which is used to transfer of power from one shaft to another shaft with the help of pulleys. The amount of power transmitted depends upon the following factor. So what are the factors? It will be depends. First one is velocity of the belt. So velocity is nothing but meter per second. So meter per second is nothing but the how much is movement. Okay, so rotation of the shaft, the tension under which belt is placed on the pulley. So tension of the belt, that is also one of the factors of power transmission. So high tension is nothing but high pressure or high load is if the load is very high, so large power can't be transfer take place. So arc of contact between the belt and a smaller pulley. Next, condition under which belt is used. These are the factors affecting power transmission from one shaft to another shaft through the belt drives. Next, selection of belt drives. The selection of the belt drive based on these many categories. Okay, so first one is speed of the driving and driven shaft. The driving is nothing but driving shaft is directly connected to motors. Based on that motor speed, this driving shaft will be rotate. Then that motion or rotation is transfer take place from this driving shaft to driven shaft with the help of belts. Okay, with the help of belts. Though selection of the belt, it depends on the driving and driven shaft. So if the driving and driven shaft is heavy loaded, so heavy type of belt is required. So high strong material belt is required. So that is also one of the uh, specification while selecting the belt drives. Next, speed reduction ratio. Then power to be transmitted, how much amount of power has to be transferred from one shaft to another shaft. For large amount of power transmission, strong belt is required, like that. Next, center distance between the shaft. If the center distance between the shaft is very low, so less center distance, then you can use a V belt type of belt drives. If the center distance is medium, around 8 meters, then you can use the flat belt drives. And then if the center distance between the two shaft is very long, so around more than 8 meter, then you should use the rope type of belt drive. These are the three different varieties of belt drives. First one is rope belt drive, second one is flat belt drives, and third one is V belt drives. So V belt drives is used for small distance, so less than 4 meter distance, then you can use for V belt drives. And if the center distance is more, then you should use the flat type of belt drives. And if the center distance more than 8 meter, then you should use the rope type of belt drives. That is also one of the parameter while selecting the belt. Okay, next positive drive requirement. So positive drives without any frictions. Next shaft layouts, then space available to transfer power. Okay, next service condition. So maintenance is required for belt drives. So that is also one of the parameter while selecting the belts. These are the parameters is required for selection of the belt drives. Next, types of belt drives. So we'll see the different types of belt drives. So first one is light drives. Light drive is nothing but what? These are used to transmit small power at belt speed up to 10 meter per second. As in agriculture machine and small machine tools. So that is nothing but light drives. If the velocity or rotation speed of the drives is less than 10 meter per second, then it is called as light belt drive. So it is mainly used in agriculture machine and small machine tools. Next, what is medium drives? Medium drives is nothing but if the transmit medium power at belt speed. If the belt speed is in between 10 meter per second to 22 meter per second, then it is called as medium drive. So it is used in machine tools. And third one is heavy drives. So what is that heavy drives? Heavy drive is nothing but these are used to transmit large power. So the speed of the driving shaft is more than 22 meter per second. Then that drive is called as heavy drives. This type of heavy drives is used in compressor and generator. So that speed is very high. In that case, this type of heavy drives belt drive is using. So based on the speed of the drives, we can classify it into three categories. First one is light drives, medium drives, and last one is heavy drives. Next, based on the shape of the belt, I already explained the shape. It is in flat shape. So the flat belt is mainly used the distance up to 8 meters. So if the distance between the two driving as well as driven shaft 8 meter, then we can use this flat shape of drives, flat shape of belt. If the center distance if the center distance is very low, less than 4 meter, then you can use V belt. Okay, V belt. So large amount of power can be transmitted with the help of wheel drives, but it can be transferred for a small distance. That is the disadvantage of V belt. So large amount of power can be transmitted with the help of wheel drives, V belt shape, but we can transfer for a small distance. That is nothing but V belt. Next, third one is circular belt. Circular belt, we can transfer large amount of power as well as for a large distance or long distance we can transfer power. That is nothing but circular belt. So most of the industrial application we are using this circular belt. Okay, so these are the three types of belt based on the shape of the belts. Next, material used for belts. So these are the materials is commonly used in belts. So leather belt, cotton or fabric belts, rubber belt and balata belts. The material is depends on the parameter. So I already explained what are the parameter is required to selection of the belt drives. Based on that parameter, we can select these materials of belts. Next, types of flat belt drive. So in that flat belt drive, so flat belt drive is mainly used for transfer of power from one shaft to another shaft, the distance up to 8 meter. If the distance is more than 8 meter, then you can't use this flat belt drive. You should use the rope belt drives. Okay, so the types of belt drives, flat belt drives, there are two different types. First one is open belt drive. Second one is crossed or twisted belt drive. So first one is open belt drive, second one is crossed or twist belt drive. So you can see here, this is open belt drive. Open is nothing but, so this is the driver shaft, and this is the driven shaft. So this shaft is connected to motors. So based on the motor shaft rotation, this shaft will be rotates. So this is a driver. So driver, then power transmission take place from this shaft to this shaft with the help of belts. Power transmission take place from this shaft to this shaft. Okay, so A shaft to B shaft power transmission take place, but there is no contact between A shaft to B shaft. So okay, next this is called as pulley. Okay, shaft is connected to pulley, so the pulley is just give support to the belts. Here also this is pulley, pulley B, and pulley B power transmission take place from belt to pulley and pulley to shaft, like that. Okay, so initially the power transmission take place from A shaft to pulley, then pulley to belt. Then this belt carries the speed of the shaft, then transferring take place from this belt to pulley and pulley to shaft, like that power transmission take place from A shaft to B shaft. So here the in open belt drive, the driver, if a driver pulley rotate in clockwise direction, driven pulley also rotate in clockwise direction only. Both are rotating in same direction. In open belt drive, both are rotating in same direction. A as well as B rotate in same direction. Okay, so then here why here you can see here, this is a tight side and this is a slack side. Slack side is always upper end of the belt, tight side is nothing but lower end of the belt. So why it is name given as tight side? Why? Because the power transmission take place from this shaft to this shaft. Here pulling action take place in the belt, so pulling action, while pulling that it becomes a tight portion. This is becomes a tight portion. So here pushing action take place from power transmission take place from this shaft to this shaft, right? So pushing action take place, so that it is a slack side, it is nothing but loose side. Okay, this is tight side. Okay, here pulling action take place, so that here lower end is a tight side, and here pushing action take place after power transmission, so it is a slack side, like this. Okay, so understood, right? What is that open belt drive and how it works? Okay, so details I will give you in the next coming slide. Why? Because you have to study the slip and creep everything in the open belt drive or as well as cross belt drive. First basic definition I already given. What is open belt drive? Open belt drive is nothing but it is in open shape and both wheels are rotating in same direction. Power transmission take place from A shaft to B shaft. So this is called as driver, this is called as driven. Okay, so next, crossed or twist belt drive, crossed or twist belt drive. So here also you can see here the belts are in cross shape, belts are in cross shape. Then it is so that it is called as cross or twist belt drive. Remaining operation is same. So here also A is a driver and B is a driven. So power transmission take place from this shaft to this shaft. Okay, but both pulley are rotate in opposite direction. Why? Because in it is cross connection, it is cross connection, so that power transmission take place. Initially the this is connected to motor. With the help of motor this shaft will be rotate, then power transmission take place from this shaft to this pulley. Then this pulley is rotating in clockwise direction, the power transmission take place this from this pulley to belt. Then here the belt will transfer the power to the driven pulley, is nothing but B pulley. So then power transmission take place from this pulley to this belt to this pulley and this pulley to this shaft. So here cross connection, then this wheel will be rotating anti-clockwise direction. So this wheel will be rotating clockwise direction. Then here this driven wheel will be rotating anti-clockwise direction. So both wheels are rotating opposite direction in cross or twist belt drive. Then slack side anyway. So here tight side is nothing but pulling action take place here. So why? Because because of that motor speed this pulley will be rotate, so tight pulling action take place here, so it is name given as tight side. And after that pushing action take place, the power is transfer take place from this pulley to this pulley, pushing action take place, so that it is called as loose side or slack side. Okay, so then what is the disadvantage of cross belt drive? So most common application open belt drive is using. Why? Because there is no friction happens. Why? Because there is no contact take place. Belt contact takes, there is no contacts, but here the contacting take place here. Okay, because of that friction happens and the life of the belt is less. So so this is the one example. Okay, so that is nothing but cross belt drive. Understood? I hope all of you understood what is the difference between open belt drive as well as cross belt drive. Open belt drive is nothing but the driver as well as driven both are rotating in same direction, but in cross belt drive, driver as well as driven rotate in opposite direction. Next, velocity ratio of a belt drive. Velocity ratio is similar to that of the gear. Okay, it is similar to that of gears. We already studied velocity ratio in gears, but still we are studied the velocity ratio of belt drive. What is that? It is the ratio between the velocity of the driver pulley to the driven pulley. So the velocity ratio is nothing but driver to driven. Okay, in gear drive also velocity ratio is nothing but driver to driven, and train value is nothing but driven to driver. Okay, so here velocity ratio of the belt drive is nothing but it is the ratio of the velocities of the driver pulley to the driven pulley. Next, length of the belt that passes over the drives in 1 minute. How we can write length of the belt? So total length of the belt that passes over the driver in 1 minute. So that is nothing but pi d. Pi d is nothing but circumference of the circle. Okay, into speed of the pulley. Into speed of the pulley. It is nothing but 2 pi r. 2 pi r or pi d. Pi d is nothing but circumference of the driver pulley. Circumference of the driver pulley. Pi d 1 into n1. N1 is nothing but speed of the first pulley, is nothing but driver pulley. So 1 is given for driver, 2 is given for driven pulley. Okay. Next, similarly, the length of the belt that passes over the follower. Follower is nothing but driven pulley in 1 minute. So how we can write? For driven, we are giving number 2. Okay, next circumference of the driven pulley is given as pi d2 into speed of the driven pulley or follower is n2. So it is given as pi d2 n2. So this is pi d1 n1 for driver, driven for pi d2 n2. Then equate both equation pi d1 n1 as well as pi d2 n2. Then velocity ratio is given as, so pi in left hand side is also pi is there, right hand side is also pi is there. Then from that remaining term is what? D1 into n1 is equal to d2 into n2. So then you can also write in that form. You can also write in that form n1 divided by n2 is equal to d2 divided by d1 in previous equation. So in that you can also conclude that what is that in this term? So speed is inversely proportional to the diameter of the pulley. Speed is inversely proportional to the diameter of the pulley. In gear drive is also same thing. Speed is inversely proportional to diameter as well as number of teeth. But here number of teeth is not there in belt drive. So that speed is inversely proportional to diameter. So that n1 divided by n2 is equal to d2 divided by d1. Then when consider the thickness, so here thickness is also considered. Some belt drive having more thickness and bit stronger compared to others, like that. Okay, so thickness, if you consider thickness, then what equation becomes? N1 divided by N2 is equal to D2 plus T plus divided by D1 plus T. Okay, when thickness of the belt T is considered, then velocity ratio becomes what happens? N1 divided by N2 is equal to D2 plus T divided by D1 plus T. So this is the final equation. I hope all of you understood what is the velocity ratio of belt drive. So velocity ratio of the belt drive, if you consider thickness, then this is the velocity ratio. If you not consider the thickness of the belt drive, then this is the equation. The speed is inversely proportional to diameter, so that N1 divided by N2 is equal to D2 divided by D1. Next, we'll see what is creep of belt. Okay, creep of belt is nothing but what? So when the belt passes from the slack side is nothing but upper end of the surface. I already told the pushing action take place. That is nothing but slack side to the tight side. So the belt is transferring take place from slack side to tight side. Tight side is nothing but lower side. A certain portion of the belt is extend and it contract take place when it belt passes from the tight side to slack side. So extension is nothing but what? Extend. Because of that pulling action, the belts may extend in the lower side. In the tight side, belt may extend because of that pulling action of the drives. Okay, pulling action of the pulley. So because of that, the tight side may extend. Okay, next slack side is nothing but pushing action. Because of that pushing action, loose belt happens. That is nothing but slack side. Because of that, what happens? Because of that pushing happens, so contraction take place. So uneven extension or contraction in the belt is called as creep. So due to these changes of length, there is a relative motion between the belt and the pulley surface. This relative motion is termed as creep. So creep is nothing but, so usually the belt is transferring take place from tight side to slack side and slack side to tight side. Slack side is nothing but loose side, or because of that pushing action it becomes loose, and in the tight side again pulling action take place and tight happens. So extend of the belt happens in tight side, extend of the belt, expansion of the belt happens in tight side. In the slack side, contraction of the belt happens. Because of that uneven extension of the belt or contraction of the belt is nothing but creep. That is term given as creep. Understood? Because of that uneven extension or contraction of the belt in while rotating, that is nothing but creep. Next, how we can denote the creep? The total effect of creep is to reduce slightly the speed of the driven pulley or follower. So it will reduce the speed of the driving pulley or driven pulley, and losses, some because of that creep some losses happens while transferring power from one shaft to another shaft. Considering creep, the velocity ratio is given by while considering the creep, the velocity ratio, what happens? N2 divided by N1 is equal to D1 divided by D2. That is nothing but velocity ratio. Along with that, you should also consider E. E is nothing but Young's modulus. Okay, Young's modulus. Okay, so then this is nothing but stress. Okay, stress develop. Okay, in the tight side as well as slack side, stress develop. So this is the equation to calculate the creep in the belt. Okay, so this is nothing but some losses happens. Because of that losses, the power transmission reduces from driver shaft to driven shaft. I already explained what is that uneven contraction or expansion in the belts. That is nothing but creep. Okay, I hope all of you understood what is creep. If you have any doubt, please ask with me personally. So next, slip of the belt, we'll see. So one more losses happens while transferring power from one shaft to another shaft. That is nothing but slip of the belt. So what is that slip? This may cause some forward motion of the driver without carrying the belt with it. So simply rotating, the pulley is simply rotating without moving the belts. That is nothing but slip. Okay, the result of the belt slipping is to reduce the velocity ratio of the system. So velocity ratio is reduces because of that slip is nothing but slip occurs. Simply the pulley is rotating but power is not transferring to the belts. Okay, so S1 it is indicated by, so S1 is nothing but driver, the slip occurs in driver pulley, it is denoted by S1 percentage. Slip between the driver and the belt. Okay, slip between the driver and the belt, it is denoted by S1. Slip between the driver pulley and belt, it is denoted by S1 percentage. S2 percentage is nothing but slip between the belt and a follower, belt and a driven pulley, So power transmission take place from driver pulley to belt, then belt to driven pulley. Like that power transmission take place. So here S1 percentage is nothing but slip between the driver and the belt, and S2 is nothing but slip between the belt and the follower. I will explain clearly what is that. So here the power transmission take place from this pulley to belt. Okay, then belt carries the power and transferring back from this belt to this pulley. Okay, like this power transmission. Initially the power transmission take place from this pulley to belt, then belt to driven pulley. Like that power transmission take place. So slip occurs in two cases. One is here slip occurs. So while power transmission take place from this pulley to belt, some slip occurs. Simply this will be rotating without carrying the belts. And one more way the slip occurs, that is here the belt is rotating, but it is not transferring to the shaft, not transferring to the followers. So in that case also slip occurs. There are two types of slip occurs that we'll see in this formulas. Okay. Next, velocity of the belt passing over the driver per second. So this is the driver. So velocity of the belt passing over the driver per second. So that is nothing but, so velocity is what is the formula for velocity? Pi d1 n1 divided by 60 meter per second. Okay, meter per second. So that is nothing but pi d1. Pi d is nothing but circumference of the circle into speed of this wheel. Pi d is nothing but circumference of this circle into speed n1 divided by 60. That is nothing but velocity. Along with that, that is actual speed of this pulley. Actual speed of this pulley is nothing but pi d1 n1 divided by 60. That is nothing but actual speed of this pulley. Understood? So because of that slip, some power will be losses. That is indicated by S1 percentage. Here S1 percentage, here S2 percentage. So here the power transmission take place from this pulley to belt drives. Okay, actual speed is pi d1 n1 divided by 60. Okay, actual speed, and because of the slip is nothing but S1 percentage. So slip we should multiply to this speed. So that we should subtract from the actual velocity. So pi d1 n1 divided by 60. This is actual speed of the rotation of this pulley. Because of that slip, some power will be losses. How much power will be losses? That is nothing but pi d1 n1 divided by 60 into S1 percentage. How we can write percentage? S1 divided by 100. This whole thing we should subtract from this velocity. So here pi d1 n1 divided by 60, take common, then remaining thing is what? So that is 1 minus remaining thing, this already we taken outside, so S1 divided by 100. This is actually this much power is transferring take place if the slip occurs in the belt as well as driver pulley. Okay, so next, velocity of the belt passing over the follower per second. Then same power, this power is transferring take place through this belt and passes to the driven pulley. Here also due to some slippage occurs, here some losses happens. How we can calculate that losses? Actual speed rotation of this driven pulley is how much? Pi d2 n2 divided by 60. So this is nothing but after considering all the losses. This is the speed of the driven pulley. So how much losses happens? That is nothing but this is the transferring power. Actually. So that is indicated by V minus V into some losses happens while transferring power from this belt to follower motion. That is nothing but S2 percentage. So V into S2 divided by percentage. How we can write? S2 divided by 100. So V you take common and 1 minus S2 divided by 100. I hope all of you understood. I will explain one more times. So what is that? So initially the speed of the driver pulley is V. Okay, so the driver pulley is pi d. Pi d is nothing but circumference of the circle into speed divided by 60 meter per second. Okay, then while transferring this power from this pulley to belt, some losses happens. That is nothing but S1 percentage. okay, s1 percentage. So that losses we should subtract from the actual velocity. Subtract pi d1 n1 divided by 60, actual velocity. That slippage percentage is how much? S1 divided by 100. Okay, so this is actual, this one. So v is equal to pi d1 n1 divided by 60, take common, then remaining thing is what? So 1, and here also we already taken outside s1 divided by 100. This is actual velocity transferring to the belts. Oh, then same velocity is transferring and transfer to this follower. While transferring, here s2 percentage loss happens. S2 percentage loss happens. How we can calculate? Then velocity of the belt passing over the follower per second. This is the actual speed of the follower or driven pulley is how much? Pi d2 n2 divided by 60. That we know. Okay, so after considering losses is equal to what? So what are the losses happens? Actual velocity is which one? This one. Actual velocity is this one, v, minus some losses happens while transferring from this pulley to this belt to this pulley. That is nothing but s2 percentage. So v into s2 divided by 100. So we take common outside. Next remaining thing is what? 1 minus, we already taken common outside, so s2 divided by 100. Okay, so from this, so from the previous equation, so pi d2 n2 divided by 60. So v is nothing but we already derived in the previous equation, pi d1 n1 divided by 60 into 1 minus s1 divided by 100 into 1 minus s2 divided by 100. So that is equation. Just substitute the v. Okay, v is nothing but pi d1 n1 divided by 60 into 1 minus s1 divided by 100 from the previous equation. Next, here which one is common? Take outside. Okay, so pi pi cancel each other, 60 60 cancel each other. Then d2 n2 is equal to d1 n1 and this equation. So this is keep n2 here only. D2 move to denominator, n1 numerator term moves to denominator. So n2 divided by n1 is equal to d1 divided by d2, and club together is nothing but just multiply. You will get 1 minus s1 divided by 100 minus s2 divided by 100 minus minus is nothing but just multiply 1 into 1 1 1 into minus s1 s2 divided by 100. Next s1 this term into this term, s1 divided by 100 into 1 is nothing but minus s1 divided by 100. Next plus minus into minus plus s1 into s2 divided by 10,000. That is very small. Why? Because slip only slip is available, so that is very small, you can neglect that term. Okay, remaining term is this one. Next, this is nothing but s1. S is nothing but s1 plus s2. Okay, based on that you can conclude that d1 divided by d2 is equal into 1 minus s1 plus s2 is nothing but s. Okay, so you just put bracket here, so you will get s1 plus s2 divided by 100. So that is nothing but s divided by 100. Final, you will get n2 divided by n1 is equal to d1 divided by d2 and 1 minus s divided by 100. If you consider the slip in the belt, then this is the actual equation. That is nothing but n2 divided by n1 is equal to d1 divided by d2. If you consider thickness, then plus add thickness also, then add thickness also into 1 minus s divided by 100. So if you consider thickness, this is your final equation. So I hope all of you understood what is that slippage occurs. Because of that slip, some power can be losses while transferring from driver shaft to driven shaft. Okay. Thank you for watching this video. If you have any doubt, please approach me. Uh, Next class, I will start with the open belt drive as well as cross belt drive derivation. Along with that, tension in belt derivation. Some problem, numerical problem is also there in this module that we'll discuss in the next class. Thank you for watching. Thank you one and all.